Hello, smart mathematicians. Let's continue with our lesson on the counting principle and probability. Right, we're saying that the probability of an event E occurring is equal to the number of ways the event can occur divided by all the possible outcomes in the sample space. The number of ways the event can occur divided by all the possible outcomes in the sample space. So let's look at this example. Tabo has five mathematics books. Tabo has five mathematics books and three physical sciences books. The books are to be arranged in a bookshelf. If the books are randomly arranged, what is the probability of all mathematics books being packed next to each other and physical sciences books also packed next to each other? So we are finding what? The probability here of all mathematics books being packed next to each other and the physical sciences books also packed next to each other. So what do we need to do? We need to find all of the possible outcomes in this sample space. Okay, and then after that we find what? The number of ways the event can occur. The event is having all the mathematics books packed next to each other and the physical sciences books packed next to each other. Okay, right. So let's start by finding all the possible outcomes in the sample space. So how do we do that? So we say total number of ways in which the books can be arranged will be 8 factorial, because here we have what? We have 8 books here. 5 mathematics books and 3 physical sciences books. This is the total number of all possible outcomes in the sample space. Now, let's find the number of ways in which the event can occur. We were saying the mathematics books are being packed next to each other and the physical sciences books are also packed next to each other. So what do? We're saying the number of ways in which the mathematics and physical sciences books are packed next to each other. We'll have mathematics books. There are how many? There are 5 of them. So for the mathematics books, we're going to have 5 factorial. Okay. And then the physical science books, there are 3 of them. We'll have 3 factorial. And then the 2 subjects is 2 factorial. Usually I use diagrams to explain this. Let's say we have our mathematics books here. This box is for mathematics. This box is for mathematics, and then physical sciences. Physical sciences. So we have 5 books here. 1, 2, 3, 4, 5. So these books can be arranged in 5 factorial ways, because there are 5 of them. It's 5 factorial ways. And then the physical sciences books can be arranged in what? 3 factorial ways. And then we have these 2 sets also. We treat them as units. So these 2. Okay. These 2, this unit and this unit can be arranged in what? In 2 factorial ways. 2 factorial ways. You see that? So that's why we have 5 factorial times 3 factorial times 2 factorial. Okay. And then we have 1,440 ways in which the books can be arranged, where we have mathematics and physical science books next to each other. So now what is the probability? What is the probability of all mathematics books being packed next to each other and physical science books also packed next to each other? We'll say 1,440 divided by 40,320. Remember, this is the total number of possible ways in the sample space. Okay, so, and you can express your probability here as a percentage. You see that? Okay, done. That's how we use the counting principle in probability.